Hey everybody, this is Larry. This is day 2 of the Leetcode Daily Challenge for July. Let me know what you think. Hit the like button, hit the subscribe button. I'm going to do the explanation first in case you're new. And then at the end, I'm going to do the live coding. So you get me to see this solve this problem live. But pretty much as soon as I saw it, I knew that it was going to be depth first search. And the question is whether you want to be clever about it. And I was like, I didn't want to be that clever about it. And I don't think you have to. And this is a very basic depth first search problem. The idea is, just figuring out. I think that using depth first search to solve it is straightforward to think about conceptually. As long as you go left to right, it doesn't matter if it's pre-order, post-order, or in order. As long as you process, because the only thing that matters is that on the same level, they process from left to right, right? Other than that, it doesn't really matter. The only thing to kind of think about is implementation details and whether okay, well, how do I get things on how do I get the lowest level on the first element and so forth, right? And these are things that you might have to consider about because there are a couple of ways to do it, and in this case, because you only have to do it once, you don't have to worry about being too fancy. You just do it in the top down order and then just reverse the list, and or at least that's what I did. Here's my code. But basically I set the answer array, which is supposed to be an array of arrays. I do a pretty normal pre-order traversal of the tree, starting with the node. I keep track of the level of the node, and every time I process the current node, I just insert it compared to the level, depending on the level, to the answer, right? And at the very end, we just reverse it so that the top becomes the bottom and the bottom becomes the top, and then that's pretty much we're done. And we just initialize empty arrays as we need them, as the levels get deeper and so forth. So far this is a straightforward problem. I suspect that it is because it's the second day of the month, and they probably will start us off a little bit easy. So I hope you do okay on this one. The live portion is coming up. Hit the like button, hit the subscribe button, and I'm gonna do this for the rest of the month, I think. So definitely check me out, leave me a comment, let me know what you think about today's problem. And the live portion will be coming up right about now. Hey everybody, this is Larry. This is the live portion of the July Leetcode Daily Challenge. Hit the like button, hit the subscribe button, and let's get started. Binary tree level order traversal 2. Given a binary tree, return the bottom up level order traversal of its node's value. From left to right, level by level, leaf to root. Given binary tree 3, 9, 20, or just this thing, return them as okay. Yeah, I mean, I think this is just standard depth first search. You could keep track of things just by going in pre-order and then putting things in the right order. I don't know if there's anything that weird about it. I mean, maybe you could be a little bit more clever with how you do certain things, but I think that's what I'm gonna do. So let's get started. It's depth first search. So we're only gonna look at each element tree node once. And then we'll go over the analysis in a little bit. Okay, I'm just thinking about so I know how I want to do it. What I'm thinking about looking back and forth a little bit is just try to think about the actual implementation detail of the data structures and stuff like that. I think I'm just going to have a list of lists. That should be okay. You can play around with other things as well, and obviously it's a little bit of a balance between running clean code and also performance. So let's just write answers. And I'm going to implement my depth first search. You can of course write another traversal if you like. And I'll do this pre-order. So let's just call it pre-order. And because the key thing to know is that we want to go left to right. yeah, so the pre-order will help us do that. So let's do level. Notice none, you'll be returned. That's the base case. If not, then while length of answer is let's see. And I think technically speaking, it doesn't matter which order tree. I'm only doing pre-order because it. Well, I mean, yeah, because I think in order and post order does the same thing as long as you do the left before the right, and as long as you hold that invariant true, it doesn't matter which order. But I prefer pre-order because it just feels natural to me. Some of this practice is less than level. So yeah. This should only happen at most once, but just for and you could prove that to yourself at home. But I usually just use these while loops because then I don't have to prove it during a competition or something like that. Of course, it's slightly slower, but it's not that much of a big deal. On an interview, you might think about that though. Okay, and then now we want to go pre-order. No dot left, level +1, pre-order, no dot right, level +1, and I know that this is not in order, even though I said that would. So inside we let's do level is append no dot well. So this will put them in order, but because we want to do it in a bottoms up order, all we have to do at the end is just reverse the answer. And that's pretty much it. I was just thinking whether I should use the in place one, but or the cool looking one-liner, but it's okay. Ooh. So maybe this is off by 1. So if these are equal, then yeah, of course. Okay. Oops. That's the only thing that I knew there was risk in, because if you look at the code, there's not much. So I knew it was. I was thinking about that during the thing, but okay. So this looks good for now. Let's put in some random-ish base cases. There's a tree, and this tree is annoying to input in on Leetcode. So I'm just going to run this real quick. Obviously, if you're at home and you're testing and stuff like that, maybe you do a little bit more. But yeah, that looks good. So I'm going to submit, and it gets accepted on the first go. Cool. So what is the complexity? So this is just linear in that we look at each node at most once, right? And again, this is pre-order. So each node can only be in this, or only be called by this function once, and each time it just does constant amount of work. So this is linear for that reason. In terms of space, well, you can't really do better than linear because that's the size of your output and size of your answer. I mean, you may jumble it, if you want to call it that, by putting in the different levels, but at the end of the day, you still have one node per element, and yeah, that should be O of n. This is pretty straightforward, pretty good practice for depth first search or recursion and variation on that. Yeah, and that's all I have for this problem. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord below, and I will see y'all tomorrow. Bye bye.